Hello guys, in this video I introduce the building of a cooling tank, and it will be used in my router milling machines. And actually I built this for a long time ago, and I use this container. Now I change to this new container. The main component is the pump, and I choose a DC motor pump. Here is the spec. It's 12 volt DC hook and 4.5 ampere, and the flow rate is 5 liter, and the pressure is 7 kilogram. Actually, the pressure should be listed in water levels, and depends on your machines. And in my machines, the nozzle position at the height of about 1.5 meter, and I check these pressures can attend to this height. And I use a power supply to operate it. Here, transformer. There is variable voltage adjustment there, and the knob, turning knob, is located at the panel there, and also the on-off switch, so I can handily control it on the panel for this cooling pump working. And there are different types of cooling pump or water pumps. Usually they use the submersible pump. That is, the pump will submerge into the water tank. But this is the cooling tank, and I found the coolant is oil and very dirty and not very good. So you can see here, this is milky color coolant, and I will use this dry pump, and all the pump will be much cleaner, and it will be located under the tank. And submersible pumps is operated by turning blade and to push the water out. But this one is a diaphragm pump, and it works similar as the piston pump, and the diaphragm is pushed back and forth, so the output waters will pasteurize. But in my testings, I found the outputs from the nozzle is good. The flow out of the coolant is steady, except when I turn it into very low voltage or low output, then the coolant will not steady. And there are two out here. One is the inlet of the coolant, the other is outlet, and there is a screw adjustment here. There is a screw here, and it's something like the limit switch for the adjustments of the maximum current draw. Over this current draw, the switch inside will be break off the voltage supply there, to prevent the motor draw too much current and overheats the power supply or damage the motor. And I set it there, and I'm marked with a white ink. And this motor will be mounted inside this rack. Under this rack, I made this wooden rack, and I can test the motor with a battery. This is 7.2 volt battery. This side is sucking. This side, this port is coming out. And I have this tube. It connect pull up and connect to the nozzle there, and here I will connect this to the output side, and from the input side, this is flexible tube, this silicone tube, and this tube will go through this hole and enters into this port, so the coolant will be circulating, and the coolant tank is about the motor level or pump level, so it will going down and also suck into the pump. About this tank, this is 9.5 liter tank, and there is sealing on the top. I drill the hole on the bottom, and also I use the brass connector, pipe connector for connection. So this is a drop plastic bottle, and I drill a lot of hole there, and also a center hole here, and this cover will put on here, and of course I need to put some glue for sealing to prevent the liquid come out. And this hex nut also I will add the sealing compound. And what is the purpose of this? The coolant will be at this level, and before going into the pipes and to the pumps, I need the coolant 100% clean. So this is the filter. I will put on this filter. This already used, so it's dark in color. I will roll it into small size and put inside here. And then turn it onto the cover. Of course, I will not solely depends on this filter. There is a big filter there. I make a wrap. You can see here. Actually, there is inside and outside. There's two stacks. This is the lower deck. You can see there is a wire mesh here, and also this is the filter. This filter used in aquarium and it's very cheap. I make this in plastic so it don't rust, but the steel wire mesh was a little. And this is the lower deck, and this is the upper deck. And this is a final mesh, and this one is stainless steel mesh. You can see there's two types of mesh there. So there will be two layers of filter for better filtration. And I'll put on here, and later on I will add plastic sheet around there to close this area for better condition. And now see the cover here. You can see there is sealant rims there, and I drill two big holes here. There is screw here, and it's something like the limit switch for the adjustments of the maximum current draw over this current draw. The switch inside will be break off the voltage supply there to prevent the motor draw too much current and overheats the power supply or damage the motor. And I set it there, and I mark with a white ink. And this motor will be mounted inside this wrap, under this wrap. I made this wooden wrap, and I can test the motor with a battery. This is 7.2 volt battery. This side is sucking, this port is coming out. And I have this tube. It connect out and connect to the nozzle there, and here I will connect this to the output side, and from the input side, this is flexible tube, this silicone tube, and this tube will go through this hole and enters into this port, so the coolant will be circulating, and the cooling tank is about the motor level or pump level, so it will going down and also suck into the pump. About this tank, this is 9.5 liter tank, and there is sealing on the top. I drill the hole on the bottom, and also I use the brass connector, pipe connector for connection. So this is a drop plastic bottle, and I drill a lot of hole there, and also a center hole here, and this cover will put on here, and of course I need to put some glue for sealing to prevent the liquid come out. And this hex nut also I will add the sealing compound. And what is the purpose of this? The coolant will be at this level, and before going into the pipes and to the pumps, I need the coolant 100% clean. So this is the filter. I will put on this filter. This already used, so it's dark in color. I will roll it into small size and put inside here. And then turn it onto the cover. Of course, I will not solely depends on this filter. There is a big filter there. I make a wrap. You can see here. Actually, there is inside and outside. There's two stacks. This is the lower deck. You can see there is a wire mesh here, and also this is the filter. This filter used in aquarium, and it's very cheap. I make this in plastic so it don't rust, but the steel wire mesh rust a little. And this is the lower deck, and this is the upper deck. And this is a final mesh, and this one is stainless steel mesh. You can see there's two types of mesh there. So there will be two layers of filter for better filtration. And I'll put on here, and later on I will add plastic sheet around there to close this area for better condition. And now see the cover here. You can see there is sealant rims there, and I drill two big holes here. And I make two sets of this plastic connector. I use the pumping tube and turn it on my lathe to have this recess, or this. I use a thicker. No, I use this one is made of two parts, and I glue them together. And also I have made another small ring here, and then this was insert into this hole, and at the back side, I put on this ring, and this ring here. So I have these two holes because in my machines the cooling will flow over the T-slot table. There are two drain holes at front. One is at front and one is at the rear. You can see this blue color. Blue color one, and also there's one on the front here. These two drain hoses will go into here, and liquid will go down into this filter and then go into the pump, and then pump to this pipe and go to the nozzle again, and it will continue circulate. And on my machine I drill this two large holes here, and I still need to figure out how to put on these two connectors, or I need to put on this here and then insert the tank into it, or I need to take it out or do it bigger and put this connector on the top, and I need to figure out how to do it. This is the front drainer tube pipes, and it will go into this pot, something like this. And one thing is that in the old days I use this container. This is a scrapped pieces. I get it without any money. It's a camera storage box, and I use it for 2 or 3 years. But this is hard material. I think it's PC material, and I use it, and also knew that it will crack since the oil-based solution will attack PC material. So after using some time, it cracks around here. So remember, don't use the PC material. And this is polypropene, and it's much better. Now all the connections were made, and coolant liquids fill this into the container up to this level. And now I try to turn on the pump. Here is the outlet tube, and you connect here. There is a switch here. You turn on it and increase. Now you can see the solution coolant coming out here. The pump is working. Now everything is ready, has been ready, and I can turn. This is pump. I turn it on. You can see here cooling coming out. This is the first cooling. And I can discharge this, and this coolant continues to flow, and it will go down to the table, the T-slot table, and you can see here the coolants go to this string hole. And the coolant will be circulated. And I can adjust this for the level. It's much more. Of course, this is a spray nozzle. I can change it to the mist coolant. I use this button to drip the water coolant down and have the gas inlet here. I have the two options. One is used as flat coolant, another is mist coolant, and use this water tank. Thank you for your watching.